Good afternoon, everybody. Can you hear me? Okay, good afternoon. So I'll start my presentation. This is going to be a series of biobank related presentation. First one will be introducing the concept and what's the idea, where are we and where are we going next, and kind of data that we are looking at, what are the sources of data, how do we make sense of it and why is it relevant to. Okay. So as most of you know, we have inaugurated the Biobank officially on the 14th of November, coinciding with Dr. Leroy's visit here and Dr. Bhaskar. So this facility is in the fifth floor of this building. We don't have much, but we are physically, we made the space there and it's ready for full run. This is a news release that happened in the local newspapers are mentioning the same. So those of you who didn't know, I thought so quickly, the overview of my talk, I'll introduce the concept of biobanking. Most of you already probably know. Looking model, what are the components of biobanking? What do we need to look into on a daily basis? And how are we concerting our efforts with the Wellness Center here currently? And I'll briefly present the demographics of the samples that we collected in the last few months and the potential impact. And feel free to stop me anytime or at the end if you have any questions, suggestions, more than welcome. Okay. So I'm sure most of you know what is a biobank, but what is the generally agreed upon definition? It's a storage place for biological samples. It could be anything. It could be a human tissue, bodily fluids such as blood in our scenario currently, DNA, and we do that all the time, right, in the labs. But what separates in a biobank context of biobank is we do link it with relevant personal health information, lifestyle information, pre-existing conditions. So for every sample that we collect, we do have corroborating associated clinical data. So that's key definition of a biobank. And ICMR defines it as an organized collection. So it has to be extremely organized and with an associated data set stored for years together. So it's not months, like the diagnostic samples or the tissues in pathology. We store it for 5, 10, 15, 20 years, 30 years. So there have been biobanks in India that are currently, organ specific biobanks that have been doing it since 20 years or so. So brief history, the first biobank, known biobank across the world, the first one was opened in the US in Washington, D.C. by the Department of Defense. So they used to collect various tissues, organs as part of their efforts. And they used to put it in the Army Medical Museum. So they never used to study on it, but it was mainly like a tissue bank. And then in late 90s, they have ISBER, which is the International Consortium for the European countries. So primarily ISBR is the well-known agency in the biobanking area that has established protocols that gave us a context. So anybody interested in biobank will uh, use the protocols. Will use the standards set by ISBR. So that's Europe-based. And coming to India, NIMHANS in Bangalore, the National Institute of Mental Health and Neurological Sciences, has been phenomenal in establishing brain biobanks. So they have access to various samples, living and cadaver samples. So they initiated a biobank exclusively for brain. So brain biobank in Bangalore, and later we had Sapien Biosciences. That was in collaboration with Apollo Hospitals. And in 2017, more recently, there's ILBS, which is Institute of Liver and Biliary Disorders in New Delhi, where they established a national liver biobank. So they have about 70,000 liver samples of various kinds. You name it, there's normal livers and diseased livers at various stages. So that's again focusing on liver. And we have Sri Chitra Tirunal Medical Sciences Institute in Trivandrum, Kerala, where they have a heart failure biobank. So anything related to failing heart, normal heart, hearts with LV dysfunction, congestive heart failure. So that's focusing on hearts again. So we are one of the very few people in this side of the globe that are ambitiously trying to expand and cater to pretty much anything that we can store and also use it judiciously for research and better clinical purposes. So that's the historical context and a quick snapshot on what's already been done across the world. So as the first one you can see it's Iceland based decode genetics that has they took 100,000 of their citizens, Iceland citizens. They collected the data and they extracted genomic information. There's Estonian Genome Project across Europe. The last one, UK Biobank, is the one I would like to highlight because they actually collected 500,000 samples from UK citizens across the country, and they did it over a period of 5 years, and then they sent it to two different places for sequencing. And it's a very interesting. They have a website. Any of you who's remotely interested should go and check it out. They have a lot of information. And just to give you the numericals, there's about 2,000 plus papers just using the UK Biobank data. So any of you can technically go write a brief proposal, get information from the UK Biobank, use their data. And I'll briefly talk about what kind of data they have. So just to give you the sequencing data they have is 2.75 times 10 to the power 6 TB worth of data. So you can imagine the magnitude of data that they have. And also in India, it's not a biobank per se, but we do have a 10K genome project, as most of you are aware, and the data analysis is being done in Bangalore. I see. I think they are planning to finish it by the end of this year. So quickly, what did the UK Biobank do? Again, this is way too ambitious at this point, but just to give you a context of what can be done, what can be studied. They did Affymetrix based sequencing, and they have pretty much studied anything. You name it, they would have looked at it. They would have looked at variants, exome sequencing, genome-wide association studies. They looked into markers of neurological pathologies, cancer, cardiometabolism, anything. So you can apply for accessing the data and see how the data shifts across regions of UK. And you can imagine if we were to do even a miniature version of this study in India, because of the wide distribution of the genetic disparities, I think we'll have very interesting data. But that's just regarding the UK Biobank. So coming to India, as I said, on the top left corner we have the first liver bank. So they have they have a lot of liver samples, and they do store other tissues and samples from because it's in Delhi. They have catchment area from Noida, Gurgaon. Anybody who likes freezer facilities can literally send them and store them. Okay. The Human Brain Museum is in Bangalore. Again, they have brain bank. They store tissues of various neurodegenerative pathologies, Alzheimer's, Parkinson's, you name it, they probably have it. And the bottom one again is the Sri Chitra Tirunal. So, looking at this, we already know, as you can imagine, there could be different types of biobanks, right? We can have a population base, so we can collect whatever we want, whatever kind of data we want from across a population group, let's say pan India in our case. It could be a disease oriented biobank like NIMHANS or ILBS. It could be a tissue biobank per se, focused, very specific, or it could be a virtual biobank. You can dump all the information, people can access it. Regardless of what the type of biobank is, the primary goal and purpose pretty much across the globe is understanding the information contained either at the genomic level or the cellular level to understand the biology for a disease of your interest so that we can develop better therapeutics. So that's one of the things, if not anything, I want you to take home after the talk. So the distinctive features of biobank, we usually collect and store biological materials. Here, as I'm going to show you, we collect genomic DNA, we collect blood samples, and I'll tell you what we do with it. But we also store the epidemiological data. So that's one of the key features. And they're not static projects like a typical lab project. You start it, you end it, you publish the results and close the project. That's not how it works, because we do collect the biological material over a period of time continuously on a very long term basis. And they're usually associated either with current very defined objectives for the project, or a more future, not yet specified purpose for the samples that you're collecting. Regardless, the idea is you grab those samples, cryopreserve them, and you, of course, you code them. So here we call the samples, we have our own internal way of labeling them, AIG Bio 260 or 110. So that gives only us the information that we can go back into our own biobank logs and then relate it to the UHID of AIG. So other than, so that's very important. That's a very key component of a biobank. And then there should be governance structures, and protecting donors' rights is a big thing. And, they typically sign consents, but at times, sometimes they come back and say, we want to retrieve. We do not want to be a part of this. So we need to have provisions of such sort. So at a broader level, what is a typical biobank process? On the left, you can see in the blue, I don't know if you can appreciate, it's an informed consent. So we have the staff who are working with us in our biobank personnel start the process by approaching the people they're not patients, they're just showing up at a health checkup here, right? So they are probably more than healthy people. So we ask them for a consent, and then if they say yes, we do collect the samples, we collect the blood, and then we process them, we extract whatever we need, and then we cryopreserve them. And we store them at either liquid nitrogen or -80, depending on the material we are talking about. So this is again, as I'm learning, I'm 3 month old into this process, and I'm 3 month old, less than 2 month old at AIG. So this gives me an overview of what is the biobank and what's the process exactly. So as you can see, we have a donor, and then at the intermediate level, we as a biobank staff or the clinicians can counsel them, ask them to give their valuable samples, explain to them, and it processes through various stages. We collect all the information, epidemiological information, the lab information, and then we have all the data sitting for analysis, of course. And we also have, we can build collaborations. We can build collaborations across AIG, internal collaborations, and we can talk to public about it, because at the AIG, the biobank inauguration, we did have considerable interest as to what it can do and how it can help the society. So that's again a discussion for a later date. There's no talk complete regarding biobank without talking ethical issues. So it's a very big deal across the globe. India, Europe, US, UK. Informed consent is mandatory in whenever you talk about biobanking, asking somebody to give their samples. We really give them the information, tell them what we are going to do. It's a part of a research study, and this is how we're going to use it. And then that consent also needs to be upgraded in real time. And as I mentioned earlier, we do anonymize the samples. There's extreme confidentiality, and there's also privacy issues that we need to look at. So the contents of biobanking, as I've been harping on since few minutes, biospecimen, that's the primary, that's the bread and butter, the specimen that's coming every day. 6 days a week, we have people going, collecting the samples, and then we put it in our workflow, process it, store the information, store the sample. And the demographic information. So in real time, as we are collecting the samples, we also retrieve the data from the medical records in real time and store it with the corroborating sample. Because let's say one of you walks in 6 months down the road and interested in a particular genomic DNA, I need to give you all the corroborating information. It's a he or a she, pre-existing conditions, what are the clinical labs, did they, appear healthy during the checkup, or at least during the time of collection of the sample. And then the documents. So informed consents, again, we bank all the informed consents. We're currently physically banking them, and pretty soon I think we're going to automate it or digitize the collection process also. So why are we interested in biobank at AIG? We have consented individuals, we're getting the specimen, we have the information. So what do we intend to do with it? or what do typically biobanks do outside? We have these cryopreserved samples. They can go into on-site research collaborations, clinicians and researchers at AHF. We can collaborate, design projects, and try to find answers to some of the questions you may have. And the bigger goal is to find better therapeutics. Of course, we'll get peer-reviewed publications and new therapeutics. This is the overarching goal of any biobank across the world. So quickly, the current workflow that we have in our biobank here at AIG is we are working synergistically with the wellness center in Tower B. So those of you who do not know, we have a wellness center in the 8th floor of B Tower where healthy individuals or families, patients, regardless, they come to AIGH, they're counseled, they can go and have a wellness checkup done. It's pretty much like your typical master health checkup. There are various parameters, pay more, you get test more on yourself. Regardless, that is the point where we interact with those individuals, potentially donors. So we have our AIG biobank staff counseling them, asking them for consents. And if yes, we get their blood right away, we bring it down to our biobank processing area in AHF currently, and we do extract genomic DNA, cryopreserve them right away, of course, with all the precautions. And also we separate plasma and freeze it. So as you can see with this just single one-step intervention, once the person is at AIG and is willing to, we already have 2 samples. So if we structure it, streamline it, and expand it, there is no stopping. Pretty much biobanks across the world collect urine, saliva, you name it, they collect it. So there's unlimited potential for biobanking platform. And once we cryopreserve the sample, again, as I said earlier, we finish our data entry and then we collate all the clinical data. So by, following day or two, we have all the labs done. We have all of the clinical parameters. I'll briefly talk about what kind of parameters we're collecting at this point. So the categories from the typical biobank flow that we have are a baseline assessment of your health status. We are not yet looking at health-related outcomes data. That's more of a long-term perspective. And there's biomarkers like typical, your lipid function, your cardiac function, renal function data, and imaging data also. So we are currently working on a process where we build up, sample collection with consents on one hand, and processing the samples and cryopreserving on one hand, and also data collection in real time for like 6 days a week. And we also can, work on specific disease-based data, COVID-19, type 2 diabetes. We can look at a lot of things depending on the interest from these samples. So I'll quickly summarize the initial demographic analysis. So we have been interested in this process since June of this year. So I only am uh, presenting data from the last 4 to 5 months. So, again, as I said, in the series of biobank related presentations, we'll have more data coming in and the clinical profiles of people and the samples that we have. So as you can see, in July month, we had close to like 1,200 people who came in, who got master health checkup done, and who consented for their samples to be used for research purposes. So that's the number of genomic DNA that we have just for that 1 month. And we have the corresponding plasma stored in -80 just for that 1 month. And so you can imagine the amount of physical lab space that we need and the dedication from our biobank staff right now who are on their toes pretty much every day. So these are the number of individuals that we saw who agreed. And as I said, about 3,000 people, about 87% said, yes, we are more than happy to be a part of your research study. We are more than happy for you to store our samples for purposes. And yes, we consent. And we had about 13% who said, one could have been like a logistics, sometimes they're fasting, right? They are antsy, they're restless. You can't blame them. And sometimes they don't understand what is it. So regardless, we had about less than 15% who said no, we are not really interested in part of our samples being stored, or we don't want to do anything research per se. So the next graph here, I show gender distribution of these consents that we have. So when I say consents, number of individuals in your head, you should go, these are the number of samples that we have, right? Genomic DNA samples or the plasma that's stored. So we have typically higher number of males who come to these health checkups, slightly higher than the female gender. And I collected only data till November. We have this going on, so we'll show more data eventually. And the typical age distribution, as you can see, from 40s to 60s is when typically a lot of people show up. Numbers wise, we are about 175 in July who are in that age group. Obviously, less than 20, not many are really worried about going for a master health checkup and looking at their labs. And the same, in once they hit 60s, 70s, again, at least the catchment that we have right now with our wellness center, this is the current profile of those individuals. And location distribution, we do get people everywhere, from everywhere across India and outside of India, but the top six regions are Assam, Telangana, and we have Hyderabad specifically. We are here. There's Andhra Pradesh, and Bangladesh, and Tripura. So these are like typically the highest number of samples. So it'll be interesting to look at the data also, because as you can imagine, we have different eating habits, different microbiome, different culture, different lifestyles, and whatnot. So all of this data can be looked at and understand how that's affecting their profiles, how that's affecting their pre-existing conditions, or if we are able to get some of these follow-up data, like a 5-year, 3-year, or whatever. How does that change? Again, this is a slide. It's all, pardon me for the mishmash of graphs, but it's just very few individuals from rest of the states. We have people from across India: UP, MP, Meghalaya, Punjab, Uttarakhand, and we have like people from US or UK sporadically up and getting their masters done. So they give the consents and we do store. But regardless, we have very heterogeneous mix of samples at this point, and that's exciting. Another thing that I want to talk also is about the diabetes. So some of them, of course, are diabetic already, and they're coming already with their history of insulin or metformin or any other you know, medications that are helping with their glucose tolerance. But a lot of them actually come in, they get their HbA1c evaluation done, and they fall in the pre-diabetic category. As you can see here, about 38% of fall in the pre-diabetic category, and about close to 30% are normal, or at least they, according to this stringent standard of HbA1c, they're not diabetic. So one catch is HbA1c alone is not enough to classify, because I think even ICMR recommends an oral glucose tolerance test. So we don't have that data. So the master health checkup, doesn't include that. And I'm just giving you this classification based on the data from what we have. But nonetheless, it's sticks with the trend, because there's a Lancet Diabetes and Endocrinology paper looking at the metabolic aspects of Indians overall, and it suggests that there's about 136 million people in India currently projected to be in the pre-diabetes category, and half of them, I'm sure, don't even know about it. And there's dysglycemia also. So any dysregulated glycemic process, there's about 236 million who eventually, some of them will go on to pre-diabetes, diabetes. The trend actually is similar to what we see. We have the pre-diabetes percentage higher than the diabetes percentage. The kind of parameters that we're looking at, or the information that we get from these health checkups, the concerns and the associated specimens that we save, these are the parameters that we have. We have complete blood picture, we have their blood grouping, complete urine profile along with their uric acid levels, diabetes status, the HbA1c along with their fasting blood sugar, and we have a cardiac evaluation. And you pay more, you're called what is called a higher whatever package, and then they do a treadmill in addition to that 2D and echo. So we have the treadmill giving us their exercise tolerance, LV status and everything that you're interested. And we typically get the thyroid profile with the thyroid stimulating hormone levels. Again, in your advanced package, we have the T3, T4 levels also coming in. And men usually we have the PSA profile done and a mammogram with or without a pap smear for pretty much all of the females. We have viral screening, imaging. This is all the data that we are collecting. So, I'm not showing it yet because we are currently crazily looking into data, updating, collation, and analysis. Near future, we'll talk about it. As I said, we have our liver function tests, renal function tests, and the lipid profile of each of these go up. And we have the associated specimen. And there's a lot of miscellaneous parameters that are on a sporadic runoff basis, depending on the existing conditions. We have their PT, we have their ferritin levels, BUN levels, acetylcholine receptor antibody levels, depending on their conditions and any diagnosis or a referral from AIG or elsewhere. So we have all of these depending on the individual. The last few minutes, I want to talk about how can we use this platform and what can we do here, what can the biobank offer. Some of them might make sense to you, some of them might not, but this is based purely on what can be done and what is being done elsewhere outside. So if not anything, biobank can be a repository for population based genomic studies. So we can use the genomic DNA that we already have, sequence it, get a lot of information. uh, Anybody who's interested in genomics have the plasma samples. And we can also, this is my idea. We not necessarily the objective of the biobank at this point, but we have a lot of those FFPE blocks after a typical path diagnosis. And you can use those, generate, have a breast cancer, a normal, and study the gene of your interest or for whatever purpose you can. And we can also use Biobank platform for non-invasive health screening. So, you can easy to collect urine sample or a mouth rinse, just give them saline solution. Ask them to rinse it, collect it. You have the DNA in there in the cup. So we can do some of those using this platform. And cancer lines can be established from fresh tumor tissues. If we have it from our internal sources, we can match it with the normal tissue and do experiments in real time, explore better options, better treatment options. You can also generate primary cell lines, different grades of disease, depending on the cases that we have here. And again, they can be used for drug validation, target drug validation, and efficacy studies of any newer drugs. And you can continuously grow them and bank them. And that's a good, resource for anybody who is interested in any of those cancers that somebody wants to look at. And the idea is you can have these curated samples with the associated information, valuable repository for both in-house AIG clinical research effects, and also if we want to cater to the outside. That's something people ask me already. Are you willing to share samples? Does AIG want? That's again a discussion for day to day. The desired impact is you can improve screening and diagnosis for a lot of things that we don't have answers yet. So one common thing, if you really look at it, is there's a research bias. Interesting papers, most of the biobanks earlier are not in this part of the globe. So we have them, about 600 biobanks exist in North America, Europe. So that's not the really genetic makeup that we have. So typically, as you can imagine, the drugs that are going to work on them, the new target drugs that are going to be delivered might not necessarily affect us. And we have a lot of information already from papers from AHF and other places where we show that the genetic makeup of a lot of the cancers, colorectal cancer, is indeed different from what we have in US, for example. So why would you expect the drugs that work there to work here in this population? We still have a lot of unknown questions. So we can address that bias, intrinsic bias of looking at only Caucasian population, only very homogeneous population in the north. So I think biobanking platform, as I put it here, can really address this disparity and give also more samples. There are a lot of people who are interested. For example, Dr. Leroy, who visited, he wants to incorporate as many, different kinds of genotypes, meaning racial profiles, into his studies. And it does make sense that you want to be represented in those kind of studies, because we are relying on the drugs that are being delivered targeting a certain group of population. Just to give you numbers, there are about 4,600 population groups across India, and 1.3 billion plus and counting. So we do not know majority of the information that pertains to this 1.3 billion. What are the we do have a certain idea about the single nucleotide polymorphisms, and we have begin to understand, but there's so much that still can be tapped. Um, I'll present this slide again later. I don't want to bore about it, but this is again telling you how we can approach better therapeutics, go for a better personalized medicine delivering platform, and how can we look at pharmacogenomics also using a biobank. So this is, I think, the last slide. So um, we do have a potential to create an unbiased, because we are not really going and getting samples only from Andhra Pradesh or Tamil Nadu. The idea is we are tapping the pan-Indian uh, sample population that we have at AIGH, that we are fortunately are able to receive. And I think this has a lot of information that can be used for generating better treatment paradigms for most of the challenging clinical. Last but not the least, I just thank people who have really helped me, Dr. Naish Reddy sir and Dr. G.V. Rao sir, who have given a lot of inputs and time and energy and devoted their uh, really a lot of time into establishing the biobank, and hopefully we will meet their expectations. And Dr. Shashkila ma'am, who's given me an opportunity to take charge of this, and all the staff of AHF who are really phenomenal in getting the samples, processing, cryopreserving, in addition to their ongoing project duties. So thank you, and questions. So we need to develop internally with the IT. The outside, yeah, that is there. So so that's a very good idea. That's a good comment. Currently, we are not. So because we are in the very, very early stages, the idea is to, yes, follow them up. But back, right, right. Question? Yeah. So blood as blood for how long? That's right. So we do extract plasma and we store it. So that's something you can use for other proteomics studies. That's one thing. We don't just store blood as blood. Uh, we I think you can keep it, let's say, for a week for the ticket. You can work on it, but you can't store it blood much. Yes. Yeah, the longer. Yes, yes. Buffy code, you can phrase it again. Yes, for very long. Right, right. So that's the idea. We want to expand and we discussion already. So interested in departments if we can incorporate. We do want that. So we just don't want only the healthy individuals part and bank the we're more than glad to serve any indication. Thank you.